Assalamualaikum warahmatullahi wabarakatuh and hi everyone. In this video, I would like to present about heuristic construction and presentation about non-routine problem solving. Before I continue with the presentation, I would like to introduce myself. My name is Nur Danisha binti Muhammad Rizwan and I am from Mathematics 3 PPISMP. And this is my index number 20251623101134. So first, let's see what is non-routine. Non-routine problems require creative solutions, logical reasoning, and open-minded thinking. They encourage students to explore multiple approaches to find the best answer. So non-routine problems is the problems that we facing every day, but it doesn't have any fixed solution or any formula that we can use to find the solution itself. Okay, now we'll see about the difference between routine and non-routine problems. Okay, routine problems is the simple tasks that follow clear step-by-step methods. So as we can see in the image above, to get the number 7, we can add between 1 and 5. So it is a step-by-step method that we can use to calculate something or problems in the calculation. And for the non-routine problems, it's the creative challenge that required exploring multiple solutions. So the image shows that a detective that looking for a solution in a puzzle. So it required the detective or students to being creative, okay, to find a solution between those puzzles, and they need to analyze between all of the situation. This image shows example of non-routine problems that require heuristic strategy. So if you can see, it is an image uh, about a hexagonal shape that consists of 6 navy blue rings on the outer layer and 6 triangle shape in the inner layer. Um, in the in those 6 rings, we have 12, 14, 11, 15, 10, and 18. Meanwhile, the inner layer on the triangle, we have 30, 23, 25, 29, 25 again, and also the question marks. So the problem here is to find the number in the question mark triangle. So to find a solution, we need to analyze the pattern or the relationship between those number in order to find the question mark. Now the crucial part is how to solve it. The heuristic strategy that have been used in this narrative problem is the first one, look for a pattern, and second one is to identify a relationship. The heuristic steps that are required is the first one, data collection. Okay, we list the pair of numbers that are connected. Okay, like 12 is near 27 and 15 is near 26. And step 2, we testing the operation. Does 12 multiplied by 2 equal to 24? No, it is 27. And next, does 12 plus 10 equal to 22? It also no. And okay, and then we move to the set 3. We analysis the relational between all of the number. Okay, we look at the neighboring numbers. How does 12 and its neighbor 15 are related to the certain number which is 27? And then the last step, rule induction. We notice that 12 plus 15 equal to 27. And now we test this rule on the second section to see if it holds true. Those heuristic strategy or heuristic steps can be represented with computational thinking components. So the first one is decomposition. The decomposition is the process of breaking a complex problem to smaller and more manageable parts. So instead of looking at the whole hexagon, we isolate individual triplets. And each triplet consists of 2 dark blue rings and the light blue triangle. There are connecting between them. And also, The next component is pattern recognition. It is required to identifying similarities or trends within the data to find a consistent rule. So from the last step, the step 4 of heuristic strategy, we have find the rule induction between all of the connected numbers. So we observe from the top that 18 plus 12 equal to 30. And on the right, 12 plus 11 equal to 23. And the bottom, 11 plus 14 equal to 25. So the trend that we can see here is that in every completed section, the center triangle is the sum of its two outer neighbors. Next, the third component is abstraction, which is removing unnecessary details to focus purely on the core logic. So we filter the Lego stars or the gray base plates and the specific shades of blue. That means we only focus on the value and the position of those numbers. And the mathematical model is we strip the physical objects away and represent the puzzle as a formula, which means ring A plus ring B equal to the triangle. Now we move to the one of the most important computational thinking components, which is algorithmic thinking. We'll be creating a repeatable set of instructions or an algorithm to solve the problem. The first step is to identify the two dark blue ring next to the question mark. And then we extract their numerical values, which are 18 and 10. And then we add them together, 18 plus 10. And then the result is the value of the light blue triangle, which is 28. Now we move to the evaluation, which is testing the solution for accuracy and identifying or fixing error or bugs. Okay, the result is 18 plus 10 equal to 28. Therefore, question mark equal to 28. Okay, to debugging, we test other operations like subtraction or multiplication and reject them because they don't work for every section. And to verify or final check, does 28 maintain the flow of the hexagon? Yes. Now, the last computational thinking components is logical reasoning. It is using the established rules and facts to make deduction and explain why a solution is correct. So the deduction is if the addition rule works for every completed segment. So using the formula that have been created just now, which is ring A plus ring B equal to triangle. So we test the rule reduction to all of the segment um, to to prove that the equation is the formula is correct. Then if it is correct, then it must be the universal logic for the entire structure. And then we can see the proof, which is 15 plus 14 equal to 29 and 10 plus 15 equal to 25. It has proved that our sum rule is mathematically sound and consistent. Before end of the presentation, we'll see about the synergy of computational thinking and non-routine problem solving. Non-routine problems are often messy and lack a clear formula. Computational thinking transforms the chaos into a structured process. So we always see the non-routine problems as one of the complicated problems that we face every day. But computational thinking helps us to analyze and process every of the information in order to find the best solution. And through the decomposition, we break the Dalton Lego hexagon into individual triplets. This prevents cognitive overload and creates a clear starting point. So to avoid the messiness, okay, we find the starting point and we analyze every step or the every manageable parts between in the knowledge problems. And instead of guessing, better recognition and logical reasoning allows us to derive a specific sum rule. The solution isn't just sound, it is engineered through a deep understanding of the internal relationships within the data. Like for example, we find the relationship and pattern between all of the triplets, and we could conclude that um, tri- ring A plus ring B equal to the triangle. So it shows the strong relationships between all of the data inside of the hexagonal shape. And next, building the heuristic for the hex logic leads to the insight that neighboring variables dictate the center outcome. This is a fundamental concept in new network theory and data science. And the solver moves from seeing shapes and numbers to seeing a functional map. The insight gained is that math is not about static numbers, but about the dynamic flow of values across a system. So by this number puzzle, we can see the same concept outside of in the real world, which is in network theory and data science. We analyze of the data, and we find the network between them, and we can make a functional map. And that's all from me. Thank you.